Hello and welcome. In this video, we are going to talk about DRAM. Okay, the very first question. What is DRAM? Okay, DRAM stands for Dynamic Random Access Memory, and DRAM memory was first marketed in the late 1960s, about 50 years ago, and was very likely the first memory integrated circuit ever sold. In this video, we will show you how the DRAM core memory works at a very high level. Okay, and in through this video, we will gonna learn about the advantages and disadvantages of this technology. This is a DRAM code. DRAM cell, one transistor and one capacitor make up one memory bit. That is only two elements per cell. By comparison, static RAM or SRAM has 6 transistors per cell and flash has 1 per cell. Through continued improvements over these 50 years, DRAM has remained the second most compact memory technology production, second only to flash memory, and unlike flash but like SRAM, it is volatile, which means it loses its data content on a power loss to the IC. But also unlike flash, but again like SRAM, it is very fast and has symmetrical read and write speeds. Here's where it sits on the price, and it's well cheaper than SRAM. DRAM is in fact the lowest price per bit symmetrical speed, which means fast reads equals fast write speed memory on our planet today, and is widely used to hold large working files, example Excel spreadsheets or Word documents, until you hit save on your PC and move the results to flash or to a hard drive. And this capacitor effectively holds the bits value. It can be charged up to a high voltage. We will call that a logic one, and we will use 1 volt for our logic 1 for this video example. Or it can be discharged to a low voltage. Which we will call a logic 0, which equals the SSR ground in this video explanation. Note that this MOS gate switch here sits over a substrate that is connected to either power or ground to make it work. Again, we will use the SS or ground in our video, and there is path from this gate is off through this reverse diode junction. Here the capacitor will discharge after some finite time and fall below the midpoint. 0.5 volts in our example. Let's say that finite time is 200 milliseconds in our case, or 0.2 of a second. So this memory cell capacitors need an occasional recharge to retain their memory value. The JET committee standard for refreshing every DRAM capacitor on and IC is every 64 milliseconds or less, and that's why this is called dynamic random access memory. Okay, it's dynamically refresh it 16 times at least at each second or risk losing your memory content. So how is the refresh done well? The trick is to have the cells refresh themselves every time they read, then just by stepping through all the address word lines and doing a read like command sequence at least 16 times a second. For every word line, will keep your DRAM data just like you wrote. It knows these are called bit lines. And these are the word lines. Word lines are decoded usually from the top bits of the address bus you send to the IC, and bit lines pass your data bus content to and from the internal memory cells. Now, high-density DRAM memory cell arrays can be thousands of cells in width and height, so both bit lines and word lines are many cells long. But to explain DRAM operations here, let's simplify to only 4 by 4 matrix. Notice there are 2 bit lines for every memory column. We will call this even and odd. These are connected to every other memory cell in the column. Each pair of even and odd bit lines must be perfectly matched in layout load and number of connections to do a refresher read step. And step 1 is to charge these even ion bit lines to the same voltage exactly halfway between 1 and 0 level. That brings this pair of inverters so exactly a midpoint roughly 0.5 volts and disconnect this charging source step to the word lines and gets the targeted cell. Let's use this one onto this even bit line. The charge on this capacitor, which is high or 1 volt in this case, adds enough positive voltage change to this even bit line to raise this. Inverter input a small amount, but that small amount is enough to push down the odd bits line through the inverter and make this return inverter drive the high level. Okay, and even higher this inverter loop continues until the even bit line is being actively driven to 1 volt by this second inverter, which then refreshes the capacitor to 1 volt. Just like we wanted, the same would have happened had we been reading as 0. The inverter pair would have refreshed the 0 volt back to the capacitor in an actual read instruction, the volt line. The word line would have then selected a full block or patch of memory cells and then the rest of the address bus bits used sent to the IC will be decoded to decide which byte or word to send to the output of the IC. Now, let's look at the write instructions. For write instruction, the targeted bit lines are driven higher or low depending on if you are writing ones or zeros, and the capacitors inside the selected memory cells are moved to those return values in DRAM memory bits. And these bits can be read over and over or written over and over infinitely without damage to the structure and without losing content that is different than flash, which has a destructive write and erase operation. Now, there are microcontrollers that include DRAM blocks inside, but the standalone parallel integrated circuit DRAM market is huge because of its wide use in industry standard committees. DRAM interface speeds, lock rates, and bus widths. In most cases, there are just too many variations to cover here in this video. Synchronous DDR, which is double date rate DIMMs and RAMs. It's a very long list, so here is our DRAM wrap up value number 1. DRAM is the lowest cost of the symmetrical read and write memories. Value number 2. DRAM is the lowest cost of the infinite write memory access, which means there is no structural damage to the part. And value number 3. Because it's a low cost, DRAM is widely available in many format speeds and packages. Let's talk about disadvantages of DRAM. The one of disadvantage is it is a volatile content will be lost on any power loss to the IC, and due attention must be paid to providing refresh cycles around 16 times each second to each memory cell. Okay, that's all, and thank you for your attention.